Okay, this is classic video 12.5 or 12.6. Copy this work onto the handouts I'm giving you, and then write down the 5 words to show me that you listen. So here we go. Knowing how to write equations from data, and then today's concept of knowing how to graph, and then check a point and see if it's a solution. So here we go. Knowing how to use data to write an equation, starting off with the old-fashioned way, how a coordinate is truly written. This data, the way it's given to you, every point is listed like an XY coordinate to put on a graph. To write this as an equation, I just focus on the change in the y numbers, since the change in the x numbers is only going up by 1, that's not going to do anything to my y numbers each time. Dividing by 1 doesn't change it. So just focus on the change in the y numbers, whether it be the normal way it's written or whether it be flip-flop like this, where the y data is on the left side of your column. We've been practicing. But here we go. With that number 4, I could look at my x number and see if it's the y-intercept or not. If it's not, I could go up or down the column, repeating this pattern, but in the opposite direction. Adding by 4 going down, subtracting by 4 going up. What am I subtracting 4 from? This 7 data point right here. So that 7 minus 4 gives me 3, that all-important y-intercept. When x is 0, whatever y is, that's the y-intercept point right there in my data. Looking at that, that's x and y, the normal way of writing it. To write this equation, I just take that y and I take that slope number. First word is hat. I take that slope number 4, put that in front of x, and then I add that or subtract it to whatever that y-intercept term is, 3. That is my equation, starting at 3, going over 1, up 4 each time, over 1, up 4. If I wanted to find this 10th term right here, all I got to do is take that 10 and plug it in for x and do the math. That will give me what y is at that spot. So to find what y is, when x is 10, I plug in 10 for that x. All the other numbers stay the same, and that gives me 40 plus 3. That gives me, when x is 10, y is 43. That's what that coordinate is. All right, and then knowing every one of these points, if I plug it in, like if I plug in 2 right here, that gives me 4 times 2 plus 3, that gives me 8 plus 3, that gives me 11. Each of these points works in that equation, that key equation. All right, now if the data is flip-flopped on you, remember these points that we're going to graph them just like we would on an XY axis, but instead of the y-axis being y, we use the y-axis as c to represent cost, and we use t for the x-axis time, knowing that these points, it looks like it's 10, 0, but it's not. These points are reversed on you. This is really the coordinate 0, 10 if I was to graph it. Remember, 0 for x, y is 10, knowing that. All right, these kinds, with the data flip-flopped on you, you could still focus on the change in that y number, which is this 13 going up by 3. That's my slope number. If I give you the 0 term, that number next to it right away is the y-intercept, that's 0, 10. So to write this equation, not using y and x, using c and t, is cost equals $3 times each time plus that $10 fee we've been talking about that you pay before you go to this pool. And then of course, if I want to know how many times, 10 times cost in that pool, just plug that in. That gives me 3 times that 10. My pen writes, which gives me 30 plus 10, which gives me the cost after going to that pool 10 times is $40. That's what that number is right there. That coordinate, which is really the coordinate 10, 40, 10 for X, Y is 40, but we're using T and C, would be plotting it the same way. Go over 10 and then go up all the way up to 40. That's where that point would be. And that represents that after 10 times that pool cost me $40. All right, next word is boot. Boot. Looking at this, it looks high tech, but none of these steps are above any of you. Today's stuff is graphing, knowing how to graph an equation already given to you. So for this, whatever number is always by itself always goes on the y-axis. The number in front of x I use as my change to get more points. So again, this number all by itself is going to go either up or down the y-axis, never on the x-axis. That is the point 0, -3. That goes right here on the y-axis, either up or down the y-axis. My next step is to look at this slope number, which is 4. If it's a fraction, you have rise and run, you're changing y, changing x. If it's a whole number like 4, you could put it and make it into a fraction, because any whole number in the universe is over 1. That tells you from that green point, I'm going to go over 1, but then from there go up 4 and keep repeating that pattern or back step it. So here I go. Right one box from this green starting point at -3, up 4. 1, 2, 3, 4. The more you practice and look at these grids, the better it will train your brain. Over 1, up 4. Over 1, up 4. Get into a rhythm. Train your brain to look at those grids. Reverse that pattern, but going down. 1, 2, 3, 4, left. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. Again, practice those patterns and then draw a line through those points. Let's do this in black. Hopefully it'll let me. All right. Draw arrows on either side of your line to show that goes on forever. And then today's work, I'm going to have you pick a point on the line, check it, and then pick a point off the line that doesn't check. So here's a point clearly on the line right there for today's work. This is going to be 2, 5. That point is on the line. If that point's on the line, when I plug in 2 for x and 5 for y into this equation over here, it's going to give me a true statement. Any point that's not on this line, like maybe use 4, 2, is going to give me a false statement, two numbers that are not true. Watch. So if I take that equation and where there's a y, plug in a 5 using that same equation over there, but now where that y is, I replace it with the y number from this point, equals, still have that 4 there from the original equation, plug in 2 from that point that's on the line, still have -3 from that original equation, gives me 5 equals 8 minus 3, and I could see clearly that's 5 equals 5. That is a true statement. Any point on that line will give you a situation like that, will make the equation work, will be a solution to that equation. Any point not on the line, like this one, if I plug in the y numbers there and the x number there, my pen lets me right, so 4 for x, 2 for y, into that same equation, it's going to give me a false statement. 2 is no way equal to 16 minus 3. 2 is no way equal to 13. There's no way, that's not true. That's a false statement. That's what always happens when you plug in numbers that are not on the line. Next word is buckle. That's going to be the third word, buckle. All right, here we go. What I'm going to have you do is do one on your own. I want you to graph this one with 3 being your y-intercept, the number that goes up or down this y-axis, always either up or down the y-axis. And then after that, you look at that number in front of x, looking at that change in x, change in y. Remember, any whole number you could put over 1. So any whole numbers over 1 will tell you where to go from that starting point. And then what I'd like you to do is, like I did you on this check, second to last word is saddle. Saddle. I'd like you to pick a point on the line and check to see if it's a solution, and then pick a point that's not on the line to check if it's a solution. So we'll do that for this equation right here. And then I'll have you turn this in. Last word is rope. Rope. Good luck. Talk to you in a bit.